All right, so the next lesson in this unit is on something called slope-intercept form. All right, so now what we're going to be doing here is we're going to take the equation, or take an equation, and basically graph it. And what we'll find is that these equations that we're going to be working with over the next few lessons, the graphs themselves will turn out to be lines. All right, so the first form is what we call slope-intercept form. Okay, so I'm just going to jump right into this first example. We're just going to graph the equation. All right, so y equals -2/3x plus 1. Okay, so we're going to graph this here by creating what they call a table of values. Okay, so hopefully you've done this before, perhaps. So basically, to create a table of values, what I'm going to do here is I'm going to pick numbers for x and plug it in here into the equation, and then work it out to get a corresponding y value. Okay, so a little bit of review from the functions unit. The x here is called your independent variable. The reason it's independent is we're just picking the values for x kind of at random, all right? Whereas y is what we call a dependent variable. Because it depends on what we chose for x. All right, so I'll just show you how this kind of works here. Let's start off by, let's pick a nice easy number here. So let's say if x I want to equal 0. And then to get my corresponding y value, I'm going to plug 0 in here for this x. All right, so therefore y is going to equal -2/3. And again, for the x, I'm going to plug in 0. So let me just choose a different color here. All right, so for that x, I'm going to plug in a 0. And then I still have the +1. Okay, so this here, okay, when I plug it in, turns out to be a number. And to work this out, -2/3 times 0 is just equal to 0. Okay, so we know that this is equal to 0. And I still have the +1. And 0 plus 1 is 1. Okay, so when x is 0, y is equal to 1 for this equation. All right, and let's just pick another number for x. So let's say I want to pick 1. So if I do that to get my corresponding y value, y equals -2/3 times 1 plus 1. Okay, so to work this out, and yeah, we're dealing with fractions, but I'm going to need to multiply this first. These two numbers together first. So -2/3 times 1 is -2/3. And to that, I need to add 1. So I'm just going to kind of jump a step and get a common denominator. So 1 is the same as 3/3. And when I add these together, remember, keep the bottom the same. -2 plus 3 is +1. Okay, so when x is 1, y is equal to 1/3. All right, let's continue on. So let's say I plug in 2. And let's see what we get here. So -2/3 times 2 plus 1. All right. And again, I'm going to multiply this part here first. Now this time, you know, I'm multiplying by 2. So I'm just going to write that as 2/1. So when I multiply those together, -2 times 2 is -4. 3 times 1 is 3. Okay. And then to that, I need to add 1. But again, I'm going to change that to 3/3. And when I add these together, again, keep the bottom the same. -4 plus 3 is -1. All right, so when x is equal to 2, y is equal to -1/3. All right, and let's just do one more here. So if I plug in 3, we get y equals -2/3 times 3 plus 1. All right, and again, now this time, oops. All right, so this time, -2/3 times 3, the 3's will actually cancel off, right? Because that 3 is the same as 3/1. All right, so -2 plus 1 is equal to -1. Okay, so, all right, so we've got some values here in the table of values. All right, so now what we can do is we can plot some points. All right, so what this means is that off the first one here, the point 0, 1 is on this line, or is on this equation. All right, so this graph, so 0, 1 is right here. All right, so 0, 1 is right there. And then I got 1 and 1/3. So 1 and 1/3 is approximately there. 2 and negative 1/3. So 2 and negative 1/3 is the next point, perhaps around there. And then we have 3, negative 1, which is like right there. All right, so what you notice here is that these points, they all line up, right? So it's in a line. And like I said at the beginning here, these equations that we're going to be graphing should all create basically straight lines. So I'm going to connect these together. Right. And if I was to continue the table of values, for instance, let's say, jump ahead to like 6. So if I plugged in 6, the 6 and the 3 reduce to 1 and 2. So negative 2 times 2 is negative 4, plus 1 equals negative 3. So the point 6, negative 3, right there, is also on the line. And you can see that, yes, it does line up. As well, on the other side here, it would extend in this direction here. So that's not the clue. That's not the straightest line, but it's supposed to extend. All right, now this is the good news. We do not need to make a table of values again, right? Because there's going to be a connection between the graph, this line, and the equation itself. All right, and right now, basically, I'm going to go through that. All right, so use this box and 0. All right. So what do we notice about this line? Well, the two things you need to know to draw a line is its location on the grid, as well as its slope, right? Because if you know the slope, you'll know the direction and its steepness. And if you know where it is, then you can draw the line, right? So hopefully that makes sense. So the two numbers that show up in this equation is negative 2 over 3 and plus 1. Okay. So let's take a look at this line. From here, if I go down 2 over 3, I hit another point that's right on that grid. That's 2 and 3. So you can see that the slope of this line here is rise over run. It's in the negative direction, so it's going to be negative 2 over 3. So this is the deal. That number in front of the x is always going to be your slope. And now to get the location, I just need to know specifically where one point is, right? So where does this plus 1? Well, if you look here at the y-intercept, this is at plus 1. So as a result, this number here, the plus 1, is always going to be your y-intercept. Right? And if you know those two things, then you should be able to draw any line on any grid. All right, so I'm just going to summarize that up down here. So in general, the slope intercept form of a line is, and you're going to see this, you hear this a lot, y equals an mx plus b, all right, where m is the slope and b is the y-intercept. All right, so whenever you see an equation that is written in this form, you can always assume that the graph itself is always going to be a line, right? And it tells you the slope and the y-intercept. So again, the number in front of the x here, number in front of the x is your slope, and the b here is your y-intercept. Right. Cool. All right, so just moving on to the next example. So now we should be able to graph this line without actually having to make a table of values, all right, just by reading the equation. Okay, so just from this equation here, you can see that the slope is going to be 3. And the y-intercept is at -2. But technically that's a point, so I'm just going to write it as 0, -2. So the other key thing here is, yeah, make sure you include the sign that's in front of the number. So the slope in this case is +3, y-intercept is -2. That should give us enough information to draw the line. Okay, so I'm actually going to start at the y-intercept because that's a point that's on the line. So I'm going to plot it right here. And then from here, I want to draw a line with a slope of 3. Okay, so remember 3 here, I know it's a whole number here, so we can rewrite it as a fraction. That's the same as 3 over 1. And again, that's rise over run. And we know that slope is positive, which means the line has to go in this direction. All right. So yeah, so from here, this starting point here, which is at 0, -2, I'm going to go up 3 units and then over 1. Okay, so yeah, so that is another point that's on the line, which is 1, 1. Now I can continue that, right? I can go up 3 and over 1, up 3 over 1, up 3 over 1. And what you'll find is all these points here will line up. And as well, right, this point here, the -2 y-intercept, I can also go down 3 and left 1, down 3 and left 1, and so on. Okay, so again, you can see that all these points here do line up, okay, with a slope of 3. All right, so the last thing here, I'm just going to connect these up kind of freehand. Best to, that's not too bad. All right, so that is the graph of the line. All right. Now the last example here is basically we're just going to go to do the other direction where we're given the graph of the line and we're going to come up with the equation. All right, and then it also has to verify the equation, which I'll go through once we find the equation itself. All right, so the two things we need to find are the y-intercept, as well as the slope. All right, so let's take a look here. Our y-intercept here, you can just see, read it off the grid here, is at -3. And the slope of this line, we know it's positive, right? Because it goes in the positive direction. And if I go up 2 units, I'm going to go over. Okay, so the slope of this here is rise or run, which is 2 over 1, which is 2. All right, so just by picking these out off the graph, I know that the equation of this line here must be y equals 2x minus 3. All right. So this should be the equation of this line. Now, the second part of this example asks you to verify the equation. So when you're asked to verify, basically what you want to do here is just take any point that's on the line, and it actually doesn't have to hit a grid. It can be in like a fraction kind of thing, but just to be safe, you actually probably want to use one that hits like the grid marks. So, you know, this point here, or down here, any one of those points, what you do is you plug it in for x and y into the equation that you found, and you want to just make sure that the left side matches the right. Okay, so again, you can use any one of these points. So I'm just going to pick one of these 5 at random, perhaps this one right here. All right, so so this point here, you can see that it's at 2, 1. And what I'm going to do there is just plug that in for x and y to the equation that we found. So when we do that, so I'm going to plug it into this equation. I'm just going to use a different color here. So for y, I'm going to plug in 1. And then for the x, I'm going to plug in 2. And we should get the left side to match the right. Okay, so the left side, it's already just one number. Here we got 2 times 2, which is 4, minus 3. We get 4 minus 3, which is obviously 1. Okay, so we did verify now. All right, so you take any point that's on the line, plug it in for x and y, and just make sure the left side matches the right. All right. You know what? Actually, let's just do another one. All right, so let's say if I didn't choose 2, 1. Let's say I'm going to use this one down here. Get my pen to work. This point here, you can see that this point is -1, -5. I'm just going to quickly do that just to show it doesn't matter what point you choose on the line. If the line is correct, if you pick a point that's on the line, the left side should always match the right. Okay, so again, plug that in for x and y. So my y value is -5, and the x value there is -1. Okay, so I get -5 equals -2 minus 3. -2 minus 3 is -5. Okay, so you'll see again that works as well. Okay, so again, you can choose any point that's on the line to verify the equation. All right, guys, cool. So that is the the equation in slope-intercept form.